Hey everyone, and welcome to the Deep Dive. We're diving into something pretty wild today.
Yeah.
The double slit experiment.
Ooh, that's a classic.
It is, and I know physics might sound a little intimidating,
Yeah, it can be a little dry.
but trust me, this is about so much more than like formulas and equations.
It really is.
This is about like what the universe is made of.
Right, like at the most fundamental level.
The atoms, how they act.
Yeah, the building blocks of reality.
Exactly. So if you've ever like looked up at the stars and been like, what is all this?
Uh-huh. Yeah.
This is the deep dive for you.
Yes, sir.
And while you're here, hit that like button and subscribe so you don't miss out.
Yes, please do. We love having you here.
Okay, so.
We've got some really cool sources for this one.
Oh, yeah. What are we looking at?
We've got a breakdown of the experiment from a leading physicist.
Okay. Always good to have an expert.
Yeah, and then also a really lively discussion from a physics forum.
Oh, cool. So we're getting like the hard science and then like the implications, the philosophical debate.
Exactly. It gets pretty wild out there in the forums.
I bet. Okay, well, let's set the stage.
Okay.
So imagine you have like a beam of light
Mm-hmm.
shining through two tiny slits.
Okay.
What do you think you'd see on the other side?
Well, logically, I'd guess two bright lines, right? Like just corresponding to the slits.
Yeah, that's what I would think too.
Right. Like if you were spraying paint through two stencils, you'd have two lines on the wall.
Exactly.
But light doesn't do that.
Oh, it doesn't?
Nope. Instead, you get this pattern.
A pattern.
Yeah, of alternating bright and dark bands, almost like ripples spreading out from the slits.
Like ripples.
Yeah.
Okay.
That's called an interference pattern. It's a classic sign of wave behavior.
Okay, wait. So light's acting like a wave.
Yeah.
I mean, that makes sense. Like waves in water, they interfere with each other, create peaks and troughs.
Exactly.
Okay, so light's a wave.
All right, now let's switch gears.
Okay.
Instead of light, imagine we fire tiny particles, like grains of sand,
Okay.
through those same two slits.
Through the slits. Okay.
What do we expect to see this time?
I'm going to stick with my paint analogy and say two piles of sand.
Exactly, one behind each slit, right?
Right.
And that's what happens when you only have one slit open.
Okay.
And here's where things get really interesting.
Oh, boy.
When both slits are open and we fire those particles one at a time,
One at a time.
we still get that interference pattern.
What a...
It's like each particle, even though it's traveling alone, somehow knows both slits are open.
Hold on. So those tiny particles, like grains of sand, they're acting like waves.
It appears so, yeah.
Spreading out, interfering with themselves. How is that even possible?
That is the million-dollar question.
Yeah.
One of our sources put it this way, and I love this quote. They said, if you can explain this using common sense and logic, do let me know, because there's a Nobel Prize for now.
Wow. So we're dealing with something really strange here.
We are.
Like these particles are breaking the rules of, I don't know, the universe? So somebody had to have tried to explain this right, like come up with some theories.
Oh, yeah, absolutely.
Like what?
Well, some people thought maybe the atoms were interacting with each other somehow.
Even though they were fired one at a time.
I know, right? Like some sort of atomic conspiracy theory.
Yeah.
But that doesn't really hold up when you consider how many particles there are and the fact that the pattern still emerges, even when they're fired really slowly, one by one.
Okay, so no atomic teamwork.
Not likely.
What else did they come up with?
Someone in the forum had this great thought experiment
Oh, yeah.
with watermelons.
Watermelons.
Yeah, they were like, what if we scaled up this whole experiment
Okay.
and fired watermelons at giant slits?
Okay.
Would they make an interference pattern too?
I don't think so.
Right.
But I see what they're getting at.
It's like, how can something so big act like a wave?
Exactly. It just doesn't compute.
And that's the thing about quantum mechanics.
It's weird.
It really is. It challenges everything we think we know about how the world works.
So where do we go from here? Like, is there anything else that's even weirder than particles acting like waves?
Oh, you bet there is.
Oh, no.
It's called the observer effect.
The observer effect. Okay, that sounds ominous.
It kind of is. It means that when we try to see which slit a particle goes through, it changes the outcome of the experiment.
Wait, what?
Yeah, if we put a detector there.
To watch the particles.
Exactly.
But the interference pattern disappears.
Poof, gone.
So the particles are like, oh, someone's watching, gotta act normal now.
Yeah, it's like they're shy.
So they stop acting like waves.
They do. They start acting like, well, particle.
Going through one slit or the other.
Just like we'd expect.
Okay, so it's not enough to just fire the particles one at a time. We can't even look at them.
It gets even weirder.
Oh boy, here we go.
If we leave the detector there,
Okay.
but secretly turn it off,
Okay.
the interference pattern comes back.
No way.
It's true.
So they know we're not watching.
It seems that way, like they're reacting to the possibility of being observed.
That's so creepy.
Right, and this is where things get really philosophical.
Oh, how so?
Because some people think this means that consciousness itself
Okay.
is playing a role.
Like our minds are affecting the experiment.
Exactly. And that's a whole other can of worms.
Yeah, bet.
But before we go down that rabbit hole,
Yeah, good idea.
let's take a step back and try to connect the dots.
Okay, yeah, let's recap.
We've got particles acting like waves,
Right.
interference patterns appearing and disappearing,
And this observer effect.
where the act of watching changes reality.
This is wild.
It is, and it all points to one of the most mind-boggling concepts in physics,
Which is
wave-particle duality.
wave-particle duality. Okay, break that down for me.
It basically means that light and matter
Okay.
can act like both waves and particles.
Both at the same time.
Yeah, it's not like they're switching back and forth.
Okay.
They have properties of both.
So like light can make those wave-like interference patterns,
Exactly.
but it can also hit a solar panel
Yeah.
and knock electrons loose like a particle.
Right. And as we saw with the double-slit experiment,
Atoms can do the same thing.
they can act like waves and particles.
This is a lot to take in.
It is. It's a fundamental shift in how we understand the universe.
So this wave-particle duality thing, it's not just about atoms and slits, right?
So it's everywhere in the quantum world.
And speaking of the quantum world.
Oh, we're going there?
Uh-huh, yeah, I am. Have you ever heard of quantum entanglement?
Oh, have I ever? It's one of the spookiest things in quantum mechanics.
Spooky how?
Imagine two particles
Wow.
linked together, no
Mhm.
matter how far apart they are.
Okay, so like across the room.
Further, across the galaxy even.
Wow, okay.
And if you measure the state of one particle,
Like if it's spinning up or down.
yeah, something like that,
Yeah.
you instantly know the state of the other particle.
Even if it's light years away. But wouldn't that mean they're communicating faster than the speed of light?
That's what it seems like.
Isn't that impossible?
According to everything we know about physics, yes.
But it's happening.
It is. It's been experimentally confirmed.
So information is traveling instantaneously.
It appears so.
This is blowing my mind.
It's one of the biggest mysteries in physics.
And it's real.
It's as real as it gets.
Okay, I need a minute to process this.
Haha, take your time.
All right, I think I'm back with you.
Haha, welcome back.
So entanglement, that's some next level stuff.
It really is.
But we were talking about the double slit experiment.
Right.
And I feel like we've gone through like a whole universe of weirdness.
We have. It's a lot to unpack.
Okay, so let's try to recap.
Good idea.
We started with like particles acting like waves.
Yeah, creating that interference pattern.
Right. And then the observer effect.
We're trying to see which slit the particles go through.
Yeah.
Makes the interference pattern disappear.
Spooky.
Totally
And then that led us to, what was it called?
wave-particle duality.
Wave-particle duality, right?
The idea that light and matter can be both waves and particles?
At the same time.
Yeah, it's mind-bending.
It really is.
But that's quantum mechanics for you.
So this double slit experiment, it's not just some like lab curiosity.
No, definitely not.
It's telling us something really fundamental about the universe. Like reality is way weirder than we thought.
And more interconnected than we ever imagined.
Yeah, especially with that whole entanglement thing.
Right, like who knows what else is out there waiting to be discovered.
Exactly. This is just the beginning.
It is, and that's what's so exciting.
So to everyone listening,
Yeah.
if your brain is feeling a little fried right now,
Totally understandable.
that's a good thing.
It means you're expanding your mind.
It means you're taking the deep dive with us.
And we love having you along for the ride.
Absolutely. So keep those questions coming.
Yeah, never stop exploring.
And don't forget to like and subscribe to the deep dive.
Yes, please do.
We'll see you next time for another deep dive into the unknown.